Now let's take a look at how we can use the limit definition of the derivative to find the derivative for a rational function, a simple rational function like 1 over x. I want to demonstrate that I'm using the limit definition, so I'm going to carefully start my notation here. The limit as h goes to 0 of f of x plus h, in this case is 1 over x plus h, minus f of x is 1 over x, divided by h. And what we have here is a complex fraction, so I think a nice first step is to rewrite this in the following way. Dividing by h is the same as multiplying by 1 over h. So instead of dividing by h here, I can write that as 1 over h times the rest of the expression, or times the top of that expression. So 1 over x plus h minus 1 over x. And now here's the key step. I want to rewrite this part as a single fraction. So the common denominator that I can use is x times x plus h. So I want to multiply the first part of the fraction, the first fraction, by x over x, and I want to multiply the second part of the fraction, the second fraction, by x plus h divided by x plus h. So doing that, I get the limit as h goes to 0 of 1 over h, and then writing that common denominator, x plus h times h. The numerator becomes x minus x plus h. But of course that minus sign distributes, and so positive x here and negative x there cancel out. And I can simplify my expression in the next line. I'm going to write the limit as h goes to 0. I haven't taken the limit yet, so I'm going to keep that there. In the numerator, I have a negative h. In the denominator, I have an x plus h times, x plus h times x. Oh, sorry about that. And h, we can see now, is a common factor in the numerator and the denominator. H is multiplied by everything else down here, and the negative h is multiplied by everything up there. And so we can rewrite our expression as the limit as h goes to 0 of just negative 1 over x plus h times x. And now this h in the denominator is not a problem anymore because it's being added to other things. I can send it to 0 and it doesn't make the entire denominator become 0. And so I can evaluate the limit. And so I can write this without the limit notation in front because I've now evaluated the limit. I get negative 1 over x times x, or more simply, negative 1 over x squared. And that's it. This expression is an expression for the derivative of the function 1 over x.